Hello everyone, and welcome to this video where I'll be taking you through an example problem on the objective, identify a curve defined by parametric equations by plotting points. So in this video, I'm going to be working at Knewton.com through their Knewton Alta homework system and just showing you one problem that you may come across related to this particular objective. And hopefully it helps you when you see other similar problems. As with most videos, I recommend that when you see the problem, pause it first, try to work it out yourself, and then watch the video, watch me do it, and then compare your work to mine, see how you're doing. Okay. So here's the question. We're asked to determine which graph. So it's a multiple choice question, but I'll draw it out first and then we'll look at the choices, and I'll also pull up the graph of this on the desmos.com free online graphing calculator site. So we're asked to determine which graph is the sketch of the curve described by the parametric equations where x of t is 6 minus 3t squared and y of t is 3t plus 1, where t ranges from -2 to +2 inclusive. Okay, so remember parametric equations, that's where your position, so the x-coordinate of the position, the y-coordinate of your position, depend on a parameter, and in this case the parameter is called t. It doesn't always have to be called t, but for the most part you'll see the letter t be the parameter. Okay, so I'll write these out. So here are the parametric equations we were given, right? X of t is 6 minus 3t squared. Just making sure I'm able to read this here. Good. All right. And y of t is a linear function, 3t plus 1. And they told us the value of t is going from -2 to +2, including the ends, right? All right, so like in a previous video, I'll make a little table where we have values of t, right? So values of our parameter. And then the next column will be the x-coordinate at that particular value of the parameter, so x of t. And the third column here, the y-coordinate at that value of t. And you can plug in, any value from any real number from -2 to +2 to get the points on this curve. But just to be nice, I'll plug in the integer values and we'll see where things are going. So I'll start with -2 for t, then -1, 0, 1, and 2, and see what the 5 points we get look like, where they're located on the xy plane. And if for some reason I need some more points to get the pattern, I'll plug in values, in between these, maybe some halves, But let's see how these 5 go first. All right, so I'm just going to say it out loud. All right, remember you do powers first, then multiplication, then addition. All right, remember you order operations. So when t is -2, plugging into the x equation, right? X at -2, -2 squared is +4, times 3 is 12, 6 minus 12 is -6, all right? So you have an x-coordinate of -6, and y at -2, 3 times -2 is -6, plus 1 is -5. All right, and I'll plot this point with an x-coordinate of -6 and a y-coordinate of -5. So I'm going to do that to the right here with a rough xy plane. And if you have graph paper or something, it will look a little better. And as I said at the beginning of the video, I'm going to be taking you to the desmos.com site as well. So we'll see a much better picture of this later. So we have -6 on the x-axis, 6, -5 on the y-axis. All right, so we're at this location. I'll mark it in red. When the value of t is -2. All right, and I might even write that next to it. Right here's where t equals -2. We're at that point. Okay, and then keep going. So again, just going to start with integer values. Plugging in -1 for t. The x coordinate when t is -1. -1 squared is +1 times 3 is 3, and then 6 minus 3 is 3. All right. And then y at -1. 3 times -1 is -3, plus 1 is -2. All right. Okay. So we're at the point, so 3 on the x, -2 on the y. So we move from this point to this point as the value of t increases, right? So t equals -2, we're over here, moving over to here when t equals -1. And I would imagine that if I plugged in values like -1.9, -1.8, -1.5, we'd get points that move from this point to this point in that direction. But we'll see later. We'll plot more points, see what the pattern looks like, and fill in the rest. All right, when t equals 0, 0 squared is 0. 3 times 0 is 0. 6 minus 0 is 6. Right, so we're at an x-coordinate of 6 when t is 0. And when t is 0, the y-coordinate is, 3 times 0 is 0, plus 1 is 1. 6, 1. So 6 for the x-coordinate, 1 for the y-coordinate, right? So now we're over here. So definitely not a straight line motion. And you might be able to have told me that seeing the square here in one of the equations, right? These aren't both linear. So more than likely not a line, but sometimes it might be if they have the same degree or whatever. But yeah, so looking at these 3 points, we're moving from here to here to here as the value of t increases. When t is 1, 1 squared is 1, 3 times 1 is 3, 6 minus 3 is 3 again, right? So we're back to the x-coordinate of 3. But the y-coordinate, 3 times 1 is 3, plus 1 is 4. So we're at the point 3, 4. 3 for x, 4 for y. And that is when t equals 1. And finally, in my table, when t equals 2, 2 squared is 4, 3 times 4 is 12, 6 minus 12 is -6, so we're back to a point with an x-coordinate of -6. And then when t is 2, 3 times 2 is 6, plus 1 is 7. There's 7 on the y-axis. So we're at this point here with -6 for the x-coordinate, 7 for the y-coordinate. And just looking at these 5 points, having experience with this, of course, the more you do these problems, the more experience you get, the better you get at identifying what they're going to look like ahead of time. But looking at these points and following from, the low values of t to the higher values of t, it looks like the graph is doing this. The points are moving in this direction, right? We're moving from that point to that point to that point, and then turning and going back to this point to this point. And you've seen this with other videos if you've been watching. For parametric equations, they usually put the orientation on there as well, little arrows, tell you where the point is moving. as the value of the parameter increases, right? So I got little arrowheads on this to show me that the point is moving along this like parabola shape in this direction as the value of t increases. So it looks like a little part of a parabola opening left, and we're starting down here, moving up to there. All right, so I'm going to go to Desmos now, desmos.com. And let's do it again. Just to really double check myself and see if my hand drawing there is actually what I'm supposed to be getting. Now I've again brought this up too in previous videos. If you want to enter at desmos.com, if you want to enter parametric equations, you have to enter them like an ordered pair. So left parentheses, and then 6 minus 3t squared was the x equation, right? The x coordinate in terms of t. And y of t was 3t plus 1, right? So you have a comma and then 3t plus 1. And the values of t, right? You see the little range of t show up when you do that. Low value -2 to the upper value of t was +2. And you can see from I'll zoom out here, you can see this just like I had in my hand drawing, this little parabola, part of a parabola opening to the left, starting down here at, this was -6, -5 was on my graph, and up here, -6, +7 was at the end of it. Now, you don't see the motion, you don't see the movement of the points as t increases. So if you'd like to see that, go to another line and do it again. Put in another ordered pair with your parametric equations, but instead of using the letter t, use a different letter. Just some other letter. I like S when it's not T. So for the first coordinate, 6 minus 3s squared, comma, second, the y coordinate, 3s plus 1. So S is acting just like T here. And then it'll ask you, instead of giving a range for T values, or range for the parameter, it'll ask you to add a slider for that variable. And you see when s equals 1, that's the same as when t equals 1, and I'll put a label here. So you're at the point 3, 4. And that was on my hand drawing, right? When t was 1, the point I plotted was the point 3, 4. And I'll change this to go from -2 to +2, just like our range of t that was given earlier. And then the steps are just how far apart you want them to be. Like if I go a step size of 1, you can see all the points that we had in our table from the hand drawing, right? When t was -2, when the parameter was -2, here it's s. I was at the point, -6, -5 down here. And then -1, 3, -2, which was on my graph by hand. 0, we were at 6, 1, which was on my graph by hand. 3, 4, when the value of the parameter was 1, and 6, 7, -6, 7. You can see that blue point moving around when the value of the parameter was 2. All right, so I'm going to go back. And I'm going to change this step size just so we can see the motion a little better. To like 100, something small. And then you hit play. I know you can't see it, but off to the left, you'll see a play button. You hit play and you can slow it down. Animation speed here. Maybe I'll even back it up to the beginning. So we're starting here when the parameter is -2, at point -6, -5. And then I hit play. And you can see as the value of the parameter increases, the orientation of the curve, the motion of the point along this curve, tracing out this curve. And you can clearly, hopefully, see this blue point moving along this red curve, right? Tracing out the curve that I drew by hand. Right. And you can change again. You can change the animation speed. You can speed it up a little bit. But yeah, you can see the orientation. You can see the motion working out. Just play around with it a little bit in Desmos. All right, so I'm going to pause that and we'll go back to the question. So clearly, when you're working through the Knewton Alta problem, it's a multiple choice question. Well, it's definitely not this first one. Looks like, oh, the second one looked good, but See, the arrows on it are pointing in the opposite direction of what we want. The curve is, the point on the curve is moving the other way. So it's not that one. So not this one either. This is a parabola opening down. It's this last one. You can see it filled in here off to the side, but the solution's already put in for me. But you see the parabola opening to the left, and the arrows on it are pointing in the direction that our point is moving in, and these are in the correct orientation. And they go through a explanation after you enter answers in Knewton Alta, and you get things right or wrong. They give you some explanation of it, but I've already gone through all that. Great, so there it is. Wonderful, and hopefully watching me do this here helps you when you come across problems like this on your own. And thank you very much for watching.